In this video, we're going to go through the worked out solutions to the 0A4 homework, which is the review for the 0A test. A couple things to know when you review for a quiz or test. You want to look at the review worksheet. That's a great resource, but you also want to look at other resources. So your notes, your homework, you can look at the book, you can look at other resources online. This is just one resource to get you prepared for the quiz coming up on Unit 0A. So, looking at this, it says the box and whisker plot shows the points Marie scored during 24 basketball games. All right, so we got our box plot. Number 1 says label the maximum, minimum, median, lower quartile, upper quartile on the box plot below. Or sorry, above. Then label the percent for each section. Well, I know the max is the highest. So this guy right here would be our max. The minimum is the lowest. So we have our minimum. The median is right in the middle, so this value right here would be our median, or I guess I said just use lowercase m. And then the lower quartile is the median of the lower half, so that's LQ. And then the upper quartile is the median of the upper half, that is UQ. All right, so and then it says also label the percent. Well, we know the median is halfway in the middle, or it's in the middle, so half is above and half is below. So if I look at that, this whole thing would represent half of the data points. Well, half of the data points would be 50%. The upper quartile is the median of the upper half. So the median of the upper half splits the top half into two equal parts. So half of a half is a fourth or a quarter. So a quarter of all the data is represented in this section. A quarter of the data is represented here, and then the same is true here, a quarter here and a quarter here. Which means that this would be 25%. This is 25%, 25%, and 25%. All right, so then we can kind of use that to help us out with this next problem. It says about what percent of the data are in the interval from the minimum to the upper quartile. Well, if I start at the minimum, I go to the upper quartile. We have 3 of those sections, 25 plus 25 plus 25. So it will be a total of 75%. From the median to the maximum, well, median is here. The maximum is here, so everything above the median would be half is above, or 50%, or you can add 25 plus 25 to give us 50% is from the median to the maximum. The lower quartile to the median, so here's the lower quartile, here's the median. If we just look at that chunk, it would just be 25% of the data. It's just a quarter of the data. Number 3 says, what percent of the data is below the upper quartile? Well, here's the lower quartile. So here's the lower quartile. What's below it is just from the lower quartile to the minimum. That's 25%. Then ask what percent of the data is below the maximum. Well, you have the maximum here. The maximum is the highest. So everything is below it. You can either add up these 25%, so realize that if the maximum is the highest, then everything has to be below, or 100% has to be below the maximum. So 100% here. All right. Scooching down, if you can still see that, number 5, what percent of the data is above the upper quartile? Well, you have the upper quartile. Above that is 25%. Looking here, what percent of the values does the box contain? The box meaning this whole thing. Well, the box goes from the lower quartile to the upper quartile, or 2 of the sections, which would be a total of 50%. What percent of the values does each whisker contain? Well, here's a whisker and here's a whisker. Again, one whisker is half of the upper half. Well, half of a half is a quarter, or 25%. Each whisker contains 25% of the data. Look at 8. In how many games did Marie score 28 points? Well, if we look at 28, 28's way up here. The maximum is at 18. So 28, she never scored 28. If the maximum is 18, that's the most she ever scored. So, in how many games did she score 28 points? 0 games. There are no games that she scored 28 points. How do we know that? The maximum number of points she scored was 18. All right, then number 9, it says, in how many games did Marie score 8 to 12 points? Show or explain your reasoning. So 8 to 12, that goes from the median to the upper quartile. So 8 to 12, that's 25% of the games. Well, if she played a total of 24 games, we can figure out what 25% of 24 is. To do that, I can convert 25% to a decimal, multiply it times 24, and if I do 0.25 times 24, that ends up giving me 6. So we can say 6 games. Make sure we have units on that answer. Now, you don't have to do it that way. You don't have to do 0.25 times 24. We could think through, well, if there's 4 equal portions, and there's a total of 24, if I divide 24 into half, half above, that means 12 are above the median. And if I divide that in half again, half of 12 is 6. So that means each one of these represents 6 games. So this part would be 6 games, lies somewhere between, she scored somewhere between 12 points and 18 points. For 6 other games, she scored somewhere between 8 and 12 points. And same here and here. So I could just say, well, what's 24 divided by 4? That gives me a fourth of 24. Excuse me, moving down to the next one. For 10 through 12. It says, 20 critics watched the movies Clever Cats and Space Dogs and rated them. Use a box plot to answer the questions. All right, so we got Clever Cats and Space Dogs. These are the number of stars they gave them. Looks like it could have been out of 10 stars. And then we got the 2 box plots here. So number 10 says, list the values of the Clever Cats 5-number summary. Well, Clever Cats here, that looks like that's a 2. This guy is a 4. That guy is a 6, 7, and an 8. All right, so the 5-number summary, we would have 2 stars. Make sure we have our units. 4 stars, 6 stars, 7 stars, and 8 stars. Where 2 is the minimum, 8 is the maximum, 6 is the median, 4 would be the lower quartile, 7 would be the upper quartile. Next question, what is the least number of stars given? Well, the least number, that is referring to the minimum. So when we look at here, the minimum for Clever Cats is 2. The minimum for Space Dogs is between 0 and 1, so that looks like it's 0.5. So the least number of stars ever given would be 0.5. For 12, can you tell from the graph if a critic gave a movie 5 stars? So it's talking about any movie. So if I look here, 5 stars lies here. So is it possible that someone gave Space Dogs 5 stars? Well, yeah, it is. You have 5 lies somewhere in this upper whisker. We don't know for sure, though, but it is possible. Then looking up here, 5 lies somewhere in here. We don't know for sure if someone gave 5 stars, but it is within this box. It's within that 25% of the ratings. So it is possible, but we don't know for sure. So looking down here, I would say not enough information. B. Now let's talk a little bit more about this. If I were to ask you the question like, did someone give it 2 stars? Well, if I look at just 2 stars for Space Dogs, that number, we don't know for sure if someone gave Space Dogs 2 stars. Because these numbers here don't have to be in the data set. Remember, when we find a median, and this is just a median of the lower half, that number doesn't necessarily have to be one of the data sets, or in this case, one of the ratings, one of the number of stars. However, when you look up at Clever Cats, the 2 here is the minimum. The minimum and the maximum are always one of the data points, or one of the numbers that is given. Where these other 3, because these are all medians of some sort, either the median of the whole set, or the median of the lower half, or the median of the upper half, you don't know for sure, because if we have an even number, of values that we're trying to find the median of, we have to split down the middle. So sometimes it would be part of the data set, and sometimes it would not. You will see that a lot on your quiz, so you want to make sure you understand which of these are necessarily part of the data and which ones are not. Flipping to the back, continuing on with Clever Cats and Space Dogs, we have this graph again. It says, did Clever Cats get 10 stars? Okay, so here we start talking about more of these. 10 stars, Clever Cats, that's higher than the maximum. So I would say no, the maximum is 8. It's not that there's not enough information. We know it's not 10 stars. The highest was 8. 14, about how many critics gave Clever Cats 4 to 6 stars? So 4 to 6, oh, that's Space Dogs, Clever Cats. 4 to 6. Well, for this one, I'm going to use a highlighter. 4 to 6 is this range right here. We know that this represents about 25% of the data. So we can either do 0.25 times however many critics there were, and if we flip back to the front, we see there were 20 critics. So 25% of 20, which would give us 5. Or we could do a fourth of 20, or take 20 divided by 4, and it still gives us 5. So either way, we would say about 5 people, or 5 critics rather, gave Clever Cats 4 to 6 stars. Moving on to 15. Approximately what percent of the Space Dogs earn 2 to 4? So Space Dogs, 2 to 4. Now that is two of the squares, 2 of the sections. So 2 to 4 is this. Because it represents the whole box, or 2 of the sections, remember that's 25%. This is 25%. So now the total would be 50%. And the question is asking what percent, so we would say 50%. 16, the upper half of the Clever Cat stars are between which 2 numbers? So upper half. Now remember, the median divides the data into its upper half and lower half. So when we look at Clever Cats, the median's right here. The upper half would be between 6 and 8. So the upper half are between 6 stars and 8 stars. Over here, the middle 50% of Clever Cats falls between which 2 numbers? Now remember, the middle 50% is that box. So Clever Cats, I'll take a different color. This box represents the middle 50% because each one of those is 25%. Excuse me. So between which 2 numbers? Between 4 stars and 7 stars. Number 18 says compare the Space Dog reviews to the Clever Cats reviews. Use information from the box plots to support your comparison. So when we compare these, there's a lot of things we could say. We could say Space Dogs has the overall lowest rating. We could say Clever Cats has the overall highest rating. We could say 50%, so these 2 boxes, of the ratings for Clever Cats are greater than or equal to the highest rating for Space Dogs. We could say all of Clever Cats never got a rating that was as low as the bottom 25% of Space Dogs. We could say that the median for Clever Cats is greater than the median for Space Dogs. So there's a lot of different comparisons we can say. You could say things like 75% of people that watched Space Dogs gave it above a 2 stars. You could say 50% of people that saw Clever Cats gave it less than 6 stars. So a lot of different information we could accept for number 18. Number 19, each whisker represents the same number of data pieces. We know that because we said each one is a fourth, right? So each one of these was 5 different critics' opinions. So then the question is, why is the left whisker longer than the right on Clever Cat's graph? So Clever Cat's, the left one is longer than the right one. So if they represent the same number of critics, then why is it one longer than the other? We know one is longer than the other because it is more spread out. The difference between the lower quartile and the minimum is greater than the difference between the upper quartile and the maximum. So the bottom 25% of ratings was more spread out than the top 25% of ratings. So that would be the explanation why. Scooching down here to the last chunk, it says use a histogram to answer the following questions. So here's a histogram. The title is Heights of Black Cherry Trees. Number 20 says give appropriate labels for the x and y axes. Well, here's your x-axis and here's your y-axis. We know that if this is the heights of black cherry trees, then a logical label for your x-axis could be heights of black cherry trees. Or we could even just say at the heights. We like to give units. And if we look over here in the problem, it says inches for the unit. So we're going to say in parentheses, inches. Now, for a histogram, we know that the y-axis, we're going to label that as frequency. So we have done number 20. We labeled the x and y-axis. Number 21, how many trees were used in the survey? Well, we got to count the total. So for this interval, we had 3. For this interval, 3. For this interval, 8. For this interval, 10. For this interval, between 4 and 6, so that'd be 5. And for this interval, we had 2. So the total, if I add all these up, 3 plus 3 plus 8 plus 10 plus 5 plus 2 would be 31 trees. Number 22, how many trees were less than 70 inches? Well, here's 70. Less than 70 would be both of these intervals, so that'd be 3 in this interval, 3 in this one, so a total of 6. So 6 trees were less than 70 inches tall. Make sure that you guys include units on your answers for each of these as well. Number 23, what percent of trees were 70 inches or taller? So we have 70 or taller. Well, we can add all these up, or we just know that it's the rest of them, right? If there's 6 that were less than 70, and there's a total of 31 trees, then the rest must be higher. So I could even just do 31 minus 6, and that would give me 25 trees. Or I could do 8 plus 10 plus 5 plus 2, and that still gives me 25 trees. But it's asking what percent of the trees. So we know it's 25 trees. It's 25 out of the 31, which is approximately 0.80645. It goes on forever. I notice that it doesn't tell me what to round to, so when I give this percent, it doesn't necessarily matter what I round to. So let's round to the nearest tenth of a percent. If I move that over 2, that would be 80.645%. Or if I round it, 80.6%. Looking at number 24, how many trees were 62 inches tall? Well, 62 inches falls about right here. We know that there's 3 trees within this range, but we don't know for sure that there's any that are 62 inches tall. Maybe all of them are 63. Maybe there's a 63, 64, and a 61. We just don't know. So for number 24, my answer is there cannot be determined. We don't know. Based on the information, can't answer that question. For number 25, how many trees were 70 inches tall to 85 inches tall? So 70 to 85. So that's all of these guys. All right. Well, that would be a total of 8 plus 10 plus 5. That would be a total of 23 trees, sorry. So that would be the first answer. Now, what percentage of the trees is this? Well, 23 divided by 31 is approximately 0.7419, which if I rounded that to the nearest tenth, I would get, well, if I move the decimals, I get 74.19%, which if I round to the nearest tenth, like I did before, 74.2%. Number 6, in which interval does the median fall, and what is the median? Well, the median we know is in the middle. So if we have 31 trees, 31 all lined out, we know right in the middle, we have 31 divided by 2, cut in half. And that's 15.5 on either side, which means really we'll have 15 on one side, 15 on the other, and then we'll have the median in the middle. Okay, so one data point will be in the middle, 15 will be above, 15 will be below. Looking over here, we have 3 and 3. 6 would be below 70. The next interval is 8. So 6 plus 8 is 14. So we know 14 are below 75, but we have to get past the 15th one. So the 15th tree would lie in this here, and so would the 16th. So we know the median lies in this interval right here. So in which interval does it fall? It falls in the interval that's from 75 to 80. Now remember that when we have these inequalities, we have 75 on the left, 80 on the right. This is a compound inequality. We have our symbols are both less than, but we include the value on the left. You do not include the one on the right. So this is how I would denote the interval. When it's asking me what is the median, unfortunately, we can't figure out what the median is. We know it's somewhere between 75 and 80, but we don't know exactly what it is. So the second part of this, our answers cannot be determined. Cannot be determined. You cannot figure out the exact median from a histogram. It's not possible. Moving on to number 27, it said, would the median or the mean be larger in this situation and why? Well, right off the bat, we know we cannot calculate the actual median or mean from a histogram. Histograms give us a range, an interval, and a frequency within that interval. But we did talk about in class that an outlier pulls the mean towards the outlier. And when we look at histograms, sometimes we can tell whether or not there's an outlier. When I look at this one, I don't really know if I see an outlier. I can't determine, I don't know if these are necessarily outliers or here. This one is pretty hard to determine. So let's talk about this. For this one, I don't think we can necessarily determine based on the intervals and the graphs, but I do want to say when you have a histogram that looks like this, something like that, we say that that is skewed to the right. These little guys are outliers. And if you recall what we talked about in class, the median would be somewhere here, and the mean is pulled towards the outliers. So your mean might be here, in which case the mean would be greater than the median. Or if you had it where it was skewed the other way, meaning you have all of these guys here, and then you have an outlier down here. Again, these outliers pull the mean towards the outlier. So the median is going to be right in the middle of the number of data. So we'll say the median would be about here. The mean is going to be pulled that direction. So in this case, the mean would be less than. This histogram does not really follow either one of these two, obviously. So in this case, I would say cannot be determined. All right, now when you look at this review does a really nice job of reviewing box plots and histograms. However, I do want you to know that there's still going to be problems on mean, median, mode, and range. So you won't see a lot of problems like that on here. What you're going to want to do is go back to your 0A1, 0A2, 0A3 worksheets, the other worksheets we've done for homework, as well as the problems in the class and your warm-ups, because you want to make sure that you can solve problems using mean, median, mode, and range. And we did a lot of those types of problems both in the notes, the homework, and in warm-ups. All right, good luck with your studying.